This video is on quadratic expressions, and it's just on the important terminology that I think you need to know when you're starting this topic. So this is actually the first video in this entire topic of quadratic expressions, and hopefully you know a little bit about the word quadratic when you hear it. But if you don't, this video will introduce you to the concepts or the terms that I need you to be able to recognize. So the first expression you should be hearing is that of a quadratic expression. Quadratic sounds more complex than it really is. When we hear the word quadratic, all it means is that the power, the highest power in your expression has to be a 2. Okay, you can't have higher than a 2. Okay, you can have terms that have a power less than 2, but you must have a squared term. Okay, so this would be a quadratic expression. So if I was going to color code it, this will be a quadratic expression. This will be a quadratic. The whole expression would be considered to be a quadratic expression. This expression over here would also be a quadratic expression. But this would not, because you can see that the highest power is 3. And this one also is not, because the highest power is, well, it doesn't have a power. So if it doesn't have a power, then we know that power is 1. This is actually a linear expression. And that's a word that hopefully you have heard before as well, which means has something to do with straight lines. But if the degree or the power, if the power of the expression is 1, then it's a linear expression. Now, the next word we're going to be looking at is the word binomial. And what a binomial means is just two, well, when you hear the word bi, it's hopefully you think something to do with 2, like a bicycle or a bicentenary, or the word bi meaning 2. So binomial just means 2 terms. Okay, so if you have 2 terms in your algebraic expression, then it's a binomial. So clearly, this is not a binomial. This is a binomial. This is not a binomial. It actually has 3 terms. I'm hoping you're guessing what the word for 3 terms is. This is a binomial, and also this is a binomial. Okay. My last term on this page that I want you to know about is the word trinomial. And if a binomial means 2 terms, well, a trinomial just refers to an expression, algebraic expression with 3 terms. So clearly that's not a trinomial. You can't be a binomial and a trinomial, so that's not a trinomial. Here's my trinomial. Okay, we've got 1 term there, a 2nd term, and then a 3rd term. So it's a trinomial, not a trinomial, and also not a trinomial. Here we've got a 2 terms, so 1 term there and a 2nd term there. So 3 new terms that I need you to know: a quadratic expression, an algebraic expression where the highest power is 2, a binomial, just 2 terms in an algebraic expression with 2 terms, and then a trinomial, an algebraic expression with 3 terms. So let's have a look at a few more words that I want you to know. The degree refers to the power. Okay, so when you hear the word degree, I want you to think of the word power, because that's another way of thinking of degree. It's the highest power in your algebraic expression. Okay, so it's the highest power. So if I look at this expression here, clearly there's only 1 term and its power is 5. Here, the highest power, well, there's the term with the highest power is 2. So the degree just refers to the power. Here, don't assume that your powers will start from biggest and go smallest, because that is not the highest power. The highest power comes from the 2nd term, and that would be a 4. So the degree just means write out the power, nothing other than the power. Where's my degree here? Not there, not there. It actually comes from my very last term, 3. Where's my degree here? There's 1, 2, 3 terms, and the degree comes from the middle term, so it is 3. The leading term is known as the term which contains the highest power. So if I go back to all these expressions and I try and look for the term containing the highest power, well, this one only had 1 term, so that means the leading term must be 3a to the power of 5. This term, when I want the leading term, I take the entire term that contains that highest power. So I've got it over here, the term that contains the highest power. And don't forget to take the sign as well. The sign belongs with that term to the right of it. Over here is the term with the highest power, so I'm going to write down 2x cubed. And over here is the term with the highest power, so I'm going to write minus y cubed. Now, the leading coefficient, very easy to find once you have the leading term. The leading coefficient is just the coefficient of the leading term. So the coefficient is the number at the front. So whatever the number at the front of that term, that means the entire coefficient. That'll be the leading coefficient. So just the number right at the front. Now, if you don't have a number, we know that in algebra, my imaginary coefficient would be a 1. So I'm going to put down a -1. So the leading term is the entire term. That's why it says the word term. But the leading coefficient is just the number, the numerical part at the front. Now, the constant term, if you look at these algebraic expressions, I can substitute or change the pronumeral to any number, and I'm going to get different values for the expression. For example, if I took this expression over here, if I change the f to 1, I'll get 2 times 1 squared plus 3, and that equals 5. But if I wanted to, I could change the f to 2, or 3, or 10. Let's change it to 10. So if I change the f to 10, then I'll get 10 squared is 100, times 2 is 200. I'll get 203. Now, what I want you to think about is when I change the f, so over here you can see I've changed the f at first to 1, and then I've changed the f to 10. Which term never changed? There's one term that doesn't change at all when I'm making a substitution for the f. And if you look, it's this number over here. That never changed. So the 1, when I replaced the 1 and then I changed the f to a 10, those created 2 totally different numbers when I changed that f. But the constant term, that is the term that has no variable, it has no pronumeral attached to it, and because it has no pronumeral, it doesn't matter how many times you change the value of this pronumeral, the constant term is constant, it doesn't vary, its value stays the same. So the constant term, the easiest way to think about it is it's the only term which just contains a number. It has no pronumeral, and that means it will not vary. So here, I've only got one term, so really the constant term, you'd have to imagine that there's a plus 0 there, so the constant term would be 0. Over here, I do have an actual constant term. I can see it. It's over here. That does not change because it is 3. It is always 3 because there's no pronumeral. Here, my constant term is 5. Now here I've got an x term, an x squared term, and an x cubed term, so my constant term must be 0. And then here I've got a y term, a y cubed term, but I do have a constant term here. I've got a constant term of 3. The last thing is just whether the expression is monic, and this is fairly straightforward. If you want to know if an expression is monic, you just need to look at the leading coefficient. If the leading coefficient is 1, then the expression is monic. So clearly that leading coefficient is not 1, so no, it's not monic. The leading coefficient here is 2. So no, not monic. The leading coefficient here is -4, so no, not monic. The leading coefficient here was 2, so not monic again. And finally here we've got a -1, but that still doesn't count. When I want it to be monic, it has to be 1. So I think all of these expressions are not monic. All right, to finish up, let's just describe these expressions. How would I describe this? Think about what you've learnt. So you've got what degree is it? What does that make it? How many terms does it have? A couple of different words to choose from. What I can see is the degree is 2. Since the degree is 2, straight away I know it's a quadratic. I can also see that there are 3 terms, and that means it's a quadratic trinomial. There are other things I can see, like the leading coefficient is 3, and the leading term is 3b squared, and the constant term is 1. So there's lots. I'm hoping you've gained a lot of vocabulary from this video. The next expression I can see it's got degree 2, so definitely once again a quadratic. But this time around it only has 2 terms. So if it has 2 terms, that means it is a quadratic binomial. Okay, so it's a quadratic binomial. I can see that the degree is 2, the leading coefficient is 4, the leading term is 4r squared, and the constant term is -5. All right, what have we got here? Well, it's definitely not a quadratic because the degree is 1. So how would I describe this? Well, I'd describe it as linear because the degree is 1. It's a linear expression, and it's also a binomial because there's 2 terms. I can see that the constant term is -2. I can see that the degree is 1. I can see that the leading term is 7p and the leading coefficient is 7. All right, last expression. I can see the degree is 4, so it's not a quadratic. That must have a degree of 2. It's actually called a quartic because the degree is 4. We actually refer to that as a quartic expression. So something else to add to your vocabulary. I have 1, 2, 3 terms, so it is a trinomial. What else can I see? I can see the constant term is 3. I can see the leading term is a to the power 4, and I can also see the leading coefficient is 1. All right, I hope this video helps you with just understanding some basic vocabulary, and I'm hoping that you can use this also in your own speech when you're describing some of the expressions you will see in this topic.